All right, in this video, we're going to look at something called molality, which is very similar to what we've already studied, molarity. It's just got a few slight differences. So molality is basically moles of solute like we had before. So that's not different. But instead of dividing by liters of solution, we're dividing by kilograms of solvent. So there's two differences. One is it's over kilograms instead of liters. The other difference is that it's not over the solution, which is everything. It's over just the solvent, which is often water. So it's kind of like a percentage, usually a part divided by a whole. Here we're dividing a part by a part. But because the water usually makes up so much of it, it's almost the same idea. But anyway, here's a situation here. We're trying to calculate the molality of a solution of salt water. And in this case, we have 40 grams of NaCl and 100 grams of water. So NaCl is our solute. And usually the solute is the one that there is less of, or it's oftentimes a solid substance. So we're going to convert that to moles. So 40 grams of NaCl, we're going to divide essentially by its molar mass. So NaCl is 58.44 grams. So we're going to calculate how many moles of NaCl we have. So 40 divided by 58.44. And we get 0.684 moles. So that's one part. And then we're going to convert the amount of solvent, in which case is water, the kilograms. So if I have 100 grams of water, there are 1,000 grams in a kilogram. So, I mean, we can do this in our heads probably, but if not, 1,000 grams to 1 kilogram, we get 0.1 kilograms. So if I want to calculate molality, I'm just going to take the moles of the NaCl divided by the kilograms of water. And when I do that, I get 6.84 molality, which is, again, moles per kilogram, or the abbreviation for this is molal, which is kind of like an italicized M. So that's how we calculate molality. So very similar to molarity, really not much of a difference. Likewise, we can have a question like this, where we know we have a certain amount of ammonia, and we're trying to make a concentration of 2.1 molal. So you can do this a number of ways. Some of you like to use the equation. We know molality is moles per kilogram. So at this moment, we don't know how much water we need. That's the denominator, the solvent. And we know we have 18 grams of ammonia. So on the side, we'll first convert this to moles. So 18 grams of ammonia, we say, well, ammonia we know is 17.04 grams of ammonia per 1 mole. So 18 divided by 17.04, get 1.056, keeping a few extra decimals here. So that is how many moles of solute we have. So we'd put that up there. And we'd solve for how much solvent we need. So if I put this over 1, cross multiply, divide, 1.056 equals 2.1x. If I solve for x equals 1.056 divided by 2.1, I get 0.503. But we got to remember that this is in kilograms because that is what this denominator is in. So if I convert that to grams, we're looking at about 503 grams of water. So there's really no major difference between this and molarity. Very similar thing. You could also do problems where you solve for the solute. But just as long as you can make that connection between the two, it's really no difference. So until next time, I am Derek Genova. Have a delightful day.